and welcome to the week 5 lesson for COMP-111. So today we're going to talk about decision structures, which are amazing constructs. Really, very few programs are written without taking advantage of decision structures, and so as a part of that, we're going to talk about comparison operators, how you would actually compare objects, and not operators, and then truth tables as well. Okay, so decision structures. The reality is you've been doing decisions, like making decisions from the moment you woke up this morning, right? So the whole purpose of decision structure is to check a condition. And if the condition is true, we're going to take one action. If the condition is false, we're not going to take that action, but we may or may not take another action. Like we may only want to take an action if something is true and do nothing if it's false, or we may want to take one action if it's true and do a completely different action if it's false. All right, and these are more commonly known maybe as an if-then or an if-then-else statement as well. So keep in mind, you've been doing these from the moment you woke up this morning. Like when your alarm went off, you had the conscious decision, if I hit my snooze, then I get an additional 10 minutes, but I'll have to rush. Otherwise, I can take my time getting up in the morning, right? So you kind of do these things all day long. If I have coffee at 10 p.m., then I'm not going to be able to go to sleep tonight. Okay, so we do these all day long. We just don't typically think of them. We don't typically go, if I hit my snooze, then I will get to sleep. You know what I mean? Like we don't do that in our mind, but really we've been doing that all day long, making decisions all day long. And so this is a really important construct when it comes to programs. All right. Sorry, I just wanted to check and make sure I had the microphone on. Okay, single alternative decision structure. So this one only takes an action if the condition is true. So there's only one action to be done. Don't do anything if it's false. So it's a single decision, okay? A single alternative decision structure. And the format for that would be if, then a space, and then we have our parentheses, and inside the parentheses is going to be the condition that you're checking. Then we'll have an open and closing curly brackets, and inside the body of those curly brackets, these are going to be the statements that we're going to execute if the condition is true. And here's how that might look. So if open paren, the age is less than 4, closing paren, then we've got our open and closing curly brackets to define the body of the if statement, and we're going to print out still a toddler. If space open paren score is greater than or equal to 90, closing paren, notice no semicolons or anything, the parentheses define your condition, then we have an open and closing curly brackets, and we're going to print out system.out.println you earned an A. Okay, so this would be an example of a single alternative decision structure where we only take an action if the condition is true, and we're not going to do anything if the condition is false. We're just going to continue on in our program. All right, double alternative decision structures means that we're going to take one action if something is true and a completely different action if something is false. And the format for that is very similar to this single alternative decision structure, with the exception of we actually have an else. So we have an if with a space and an open paren, condition, closing paren. We have an open and closing curly bracket that defines the statements we want to execute if it's true. And those could be one-to-many statements, all right? Else, and then we have an open and closing curly bracket that will define the statements that we want to execute if false. And again, that can be one-to-many with regards to what we want to execute. All right, and so here's some examples of a double alternative decision structure. So if the grade is greater than 70, and here's our open and closing curly brackets, we'll print out you passed the course, else, and then here's our open and closing curly brackets to define our else statement. We're going to say you did not pass the course. Now it's really tempting when you're writing these decision structures to always think that you need to include an else statement, but that is just not the case. There's times when you want to include an else, and there's times when you don't want to include the else. You really just have to look at the program itself. Okay, comparison operators. So to compare, we're going to use the same comparison operators that you're used to seeing in math. We have your greater than, a greater than or equal to, a less than, or a less than or equal to. Okay, so these are the exact same comparison operators you're used to seeing. One little caveat here, it's always greater than or greater than equal. It's never equal greater than, it's never equal less than. It's always the greater than or the less than symbol first, and then the equal sign when you're looking for greater than or equality. Okay. The other comparison operators, when we're strictly looking for equality, we're going to use the double equal sign, not the single equal sign. The double equal sign tests for equality, where the single equal sign is for assignment. So it's assigning a new value to a particular variable. And we also have the exclamation equal. This is not equal, so it tests if a value is not equal to another. And there's times when you're looking for equality or not equality, when it serves your purpose to look for equality and take an action based upon that. And then there's also times when it makes more sense to look for not equal and take an action based upon not equal. So for example, if I was accepting in a gender and I know the gender needed to be male or female, I could say if the gender is not equal to male and the gender is not equal to female, then it's an error because it's an invalid gender. Versus, I don't really want to say anything to the user about it being a valid gender. I only want to alert their attention if it's an invalid gender. Excuse me. So it makes more sense in that circumstance to use a not equal than it would to use the double equal sign to test for equality. And here's an example. If space open paren x equal y, and then we've got our open and closing curly brackets, we're going to print out the message x is equal to y. And for the not equal, we have if space x not equal y, with our open and closing curly brackets to define the body, we're going to say x is not equal to y. All right, so these are very basic examples, but they show you the format on how you would use these constructs. All right, when you're comparing string objects, now this one is a little bit dicey. Remember, string data is not primitive data. String data is an object, okay? So it's not even just string objects, but objects in general. You cannot use the double equal sign to check for equality. The double equal sign is going to check to see if these are the exact same object, meaning that there's two different variable names that point to the same location in memory, all right, that point to the same object in memory, not that they contain the same value. If you want to check to see if two string objects actually contain the same value, you need to use one of the string methods that tests for equality. So you can use the dot equals method, and here we have string 1 dot equals string 2. This checks to see if they're exactly the same down to the case and everything. All right, so equals equals checks to see if they're the same object in memory, same location in memory. The string 1 dot equals, and then in here is the second string, so you're comparing string 1 to string 2, compares to see if these two contain the exact same letters down to the case. Okay, so for example, if we have string temp1 equals comp-111 and string temp2 equals comp-111, if we have the statement if temp1 equal temp2, the result is going to be false. These are two completely different objects, two different memory locations. They're not the same, so it's going to return false for you. However, if we have temp1 dot equals temp2, and we pass temp2 as a parameter to the equals method that's called from temp1, then it will compare these two string values, checking the case, not only the characters, but the case, and because they are exactly the same string value, it's going to return true. Okay, this is really something that you want to pay close attention to. It's really easy to forget that you're comparing objects, and it's especially really easy to forget that a string is an object because we're so used to using it in conjunction with all of our primitive data types that we tend to forget that the string is an object, but it is indeed an object, and you can't use the double equal sign for comparison. Okay, So there are some other methods that you can also use when you're comparing strings. So the dot equals says they have to be exactly equal, including the case. Everything has to be equal right down to the case level. Okay. Dot equals ignore case says as long as the characters are the same, I don't care if one's capital and the other's lowercase. If all the characters match, then let's consider these strings the same. And then we have the dot compare to with your string value. This one is going to help you with sorting when you're sorting items. So it's going to return 0 if they're exactly equal. It's going to return a value less than 0 if the string comes before. So if this string comes before the other string alphabetically, and a value greater than 0 if it comes after. Okay, so the dot compare to is typically used when you're sorting things in alphabetical order, or technically we would say lexicographic order, because we're sorting not only in alphabetic order but also in case order as well. Okay, now we've said you can't use the equal when you're testing string objects, but the reality is you can't use it when you're testing any object. Okay, it will always check to see if they're the same object in memory, not to see if they contain the same values. And so here's an example. We have our dog, so we're calling our dog constructor and creating a dog1 object, and then we're calling our default constructor again and creating a second dog2 object. So these are two different dog objects, two different locations in memory, two different object variable names, dog1 and dog2, but they both contain the same initial values, right? Unknown for the name, unknown for the breed, and 0 for the age. If we say if dog1 equal dog2, despite the fact that all of their instance variables contain the same values, this is going to return to us a value of false because they both have their own location in memory. All right. On the other hand, if we do this, if we say dog1 equals new dog, and then we say dog2 equals dog1, what we've done is we've created one object but with two object variables. So let's go back here to this previous one. Think of this as being twins. Okay, they look exactly the same, right? They both contain the same values, so these are twins. However, if you make a change to dog1, it is not going to make a change to dog2, right? And likewise, if you make a change to dog2, it will not make a change to dog1. So think of this as twins. They look exactly the same, but if you were to cut the hair of one twin, it has no impact on the hair of the other twin, right? Unless they then choose to also cut their hair. So, or if I don't know, if this one twin dyes their head red, the other twin's hair is not automatically dyed red, okay? And this example here, think of as one person but with two names. Maybe think of like somebody who's named Matthew who also responds to Matt. Okay, so dog1 equals new dog points to an object in memory, and then dog2 equals dog1 also points to the same object in memory. So if you call him Matthew or if you call him Matt, it doesn't matter. If Matthew cuts his hair, Matt's hair is also cut. It's the same person, two names. So that's how you want to think about it. And in this case, if we say dog1 equal dog2, this is going to become true because dog1 and dog2 both point to the same object in memory. All right. Now, if you wanted to test two objects to see if they contain the value, if you wanted to provide an equality method, a dot equals method in your class, you have to write one. Okay? If you believe that one of the requirements of your particular class is that they're going to be comparing objects, then you need to provide a way for it to be compared. So I'm just going to run through this just so hopefully it solidifies in your mind the dot equals method a little bit. We're not expecting you to write any code like this, but I just kind of want to walk this through you. Okay, so what we would have to do is we'd have to write a dot equals method ourselves in our own user-defined data type class. It's going to be public so anybody can call it. Boolean because it's going to return a value of either true or false. Equals is the name, and we're passing in the same data type as what we've originally got. Okay, so we're going to be comparing our current object against this object that's passed in. And then what you have to do is you have to check each instance variable. And this is how it would look. So we have public boolean returning true or false equals, and we're passing in a dog object. So we're going to call the instance variable for our implicit object, right, of our implicit parameter, our object that we're acting upon. So this dot name dot equals, this dot name is a string data type, so this dot name dot equals, and then we're going to retrieve the name. So we're comparing the name of our implicit object against the name of our explicit object here. And if that is equal, then we're going to check the breed, which is also data type string. So we're going to get the breed of our implicit and compare it against the breed of our explicit. And if that's equal, so the name is equal and the breed is equal, then we're going to come down here and we're going to compare the age. So we're going to say if the age, and the age is integer data type, which is primitive data, so we can use the equal symbol. So if the age is equal to the age of our explicit, then that means our name is equal, our breed is equal, our age is equal, so we're going to return true. Otherwise, we get all the way down here, we've checked those, we're going to return false. If we hit this part, then something wasn't equal and we're going to return false. So this is what has to happen when you're comparing objects, okay, if you want to test for equality of objects. All right, the and, or, and not. So these allow us to combine together two or more conditions. So we can say if condition 1 and condition 2. So if condition 1 is true and condition 2 is true, then we want to take some action. Or we could say if condition 1 or condition 2, if either one of those is true, then take some action. So in an and scenario, both conditions have to be true for the whole thing to be considered true. And in an or condition, either condition could be true for the whole thing to be considered true. But both would have to be false for the whole thing to be considered false. And so this is how this looks. With the and, you're going to use the double ampersand. Okay, and both conditions have to be true, and they have to be full conditions on either side of the and symbol. So if x is greater than y and x is greater than z, then we're going to take some action. Okay, well, as I said, each condition must be its own separate condition. So we can't use this algebraic y is less than x is less than z. This is not valid. The computer will give you an error on this. But what you can do is you can say y is less than x and x is less than z. So this is a complete condition that equates to either true or false. And this is a complete condition that equates to either true or false. And so this is valid. The or is represented by a double pipe symbol. And again, at least one condition must be true for the whole thing to be true. So here we have if x is greater than y or x is greater than z, then we're going to take some action. All right, checking ranges. So this is a real common function of using your ands and your ors when you're checking ranges. You want to check to see is a value inside of a range or is a value outside of a range. When you're checking for a value inside of a range, you want to use the and remember that's represented by the double ampersand. When you're checking for a value outside of the range, you want to use the or, and that's represented by a double pipe. Okay, and we're going to walk through an example of why you would use the and why you would use the or. All right, so let's assume that our variable x has a value of 42. Okay, and we have this statement, so our range is 10 and 20. So if x is greater than or equal to 10 and x is less than or equal to 20, meaning it's between 10 and 20 inclusive, then we want to take some action. We're going to say that we're inside the range. Okay, so remember x has a value of 42, so we're going to do the first condition first. Is x greater than or equal to 10? And yes, it is, so this is true. Okay. Then we're going to check the second action. Is x less than or equal to 20? 42 is not less than or equal to 20, so that's false. We end up with a true and false. However, both sides must be true in order for the whole thing to be true in an and situation. And so it returns a value of false because 42 is not in between the values of 10 and 20 inclusive. All right, so now we're going to assume x has a value of 2. Same condition here, same range. So 10 is less than or equal to x. 10 is less than or equal to 2. That is not true, so that gives us a false statement. X is less than or equal to 20. So we have 2 is less than or equal to 20, and that is true. So we end up with false and true. And again, remember, both sides have to be true for the whole thing to be true. So this result is false. 2 is not between the values of 10 and 20 inclusive. And last, we're going to go with a value of 12. All right, 10 is less than or equal to x. So 10 is less than or equal to 12. That is true. X is less than or equal to 20. So 12 is less than or equal to 20. That is also true. We end up with true and true. So, and both sides have to be true for the whole thing to equate to true, and they are, and so the result is true, and 12 is indeed between 10 and 20. Now, please notice what I did here when I was doing this if statement. These are really easy to mess up. Okay, really easy to make errors on them using ands or using ors. So what I did is I took values that I knew, I already knew the result, right? I already knew 42 was outside of the range. It was higher than the upper range. And I already knew 2 was outside of the range, that it was lower than the low range. And I knew 12 was inside the range. But I ran through the if statement trying each value to make sure it gave me what I was expecting. All right, and that's what you want to do, especially when you're first starting out writing if statements. You want to really run through some values that you already know the answer to make sure you're getting the result that you're expecting. All right, so we're going to try this with the OR just to see what would happen if we were in an OR, checking inside of the range. So again, we're assuming x has a value of 42, which we already know is outside of the range, right? But we're going to do it with an OR. So we have 10 is less than or equal to x, or x is less than or equal to 20. So 10 is less than or equal to x, and that is indeed true. 10 is less than or equal to 42. X is less than or equal to 20, and we know that's false because 42 is less than or equal to 20. So we end up with true or false, but in an OR situation, if either side is true, then the whole thing is true. So the result here becomes true, not false. Even though we know 42 is not between 10 and 20, it's not inside of the range, we end up with a true statement. And the reality is it doesn't matter what value I supply for x. In this particular statement, it will always be true because either the number will always be greater than or equal to 10. It could be 1,000,000, it could be 2,000,000, it could be 1,000,000,000,000, right? It will always be greater than or equal to 10, or it would be less than 20. It could be negative 1,000,000, and that's less than 20. So if I were to put an or here instead of an and, it will look like every single number is inside of the range. So you really, really, really have to be careful when you're choosing your ands and your ors for range checks. Okay, when you're looking for something outside of the range, you want to use the or. Okay, so here we have our value of 42, so we're looking for something outside the range. So x is less than 10, and we don't have less than or equal because remember 10 and 20 are inclusive inside of our range, so we're just doing less thans here. So x is less than 10, or 20 is less than x. So if x is less than 10, 42 is not less than 10, that's a false. 20 is less than x, 20 is less than 42, that's true. So we have false or true. Either side is true to equate to true, so it is true, and 42 is not. It's outside the range. It's not inside the range 10 to 20. Okay, our value of 2, which again we already know is outside the range, so let's just see what happens. X is less than 10. Here we have 2 is less than 10. Yes, that's true. 20 is less than x. 20 is not less than 2, so that's false. We have a true or false, and so we end up with true in an or situation. If either side is true, the whole thing is true, and so 2 is not in the range 10 to 20. And then when we check our value 12, which we know to be inside of the range, x is less than 10, 12 is less than 10, that's false. 20 is less than x, 20 is less than 12, that's false. We end up with a false or false. Both sides must equate to, well, either side equates to true for the whole thing to be true. So the result is false. And 12 is not outside of the range. It actually is inside the range. Now, if we were to do this with an and instead of the or, if we were trying to check for outside of the range with an and statement, and we'll assume a value of 42, which we know to be outside of the range, so we have x is less than 10 and 20 is less than x. So x is less than 10, 42 is less than 10, that's false. 20 is less than x. 20 is less than 42, that's true. We end up with false and true. Both sides have to be true for the whole thing to be true, and so the result is false, even though we know that 42 is not between 10 and 20, it is outside of the range, it would still give us a false. And so what ends up happening is x can't be both less than 10 and greater than 20 at the same time. And so if you mistakenly put an and in there, you will always end up with a false statement no matter what. All right, the not. This reverses your result. So if your result was true, it becomes false. If it was false, it becomes true. So it always reverses whatever the answer is. So it is represented by the exclamation sign here. And so it would be not, and then you have your parentheses, and it reverses whatever is inside of the parentheses, okay? So if it was true, it becomes false. If it was false, it becomes true. So you can say if x is not equal to y, that's a valid statement. You can say if not, and then in parentheses, x equal y, so you can first check for equality and then reverse that result. But you cannot say not x equal y. What this does is it says I want you to not the value that's in x, and then that is what I want you to compare to y. So what you're wanting to do here is first compare x to y and then reverse the result, not reverse the result of x and then do your comparison. Okay, so you want to just be careful with that. All right, truth tables. So you're going to be encountering some truth tables this week, and if you've taken discrete math, you may have already encountered truth tables as well. These are just a way to help you gain an understanding of the outcome of your statements when you're combining ands and ors and nots together. So truth tables are actually a good way to test your decision structures. So come up with your own values for your truth tables and run your statement through it, your decision structure through it, to make sure you're getting the output that you're expecting. But here's how a truth table would work. So we have three variables, A, B, and C. And we've got this statement here, this decision structure here, A and B in parentheses, so that's going to happen first, or C. All right, so initially in the truth table, everything contains a value of true. So we substitute in whatever the values are for the particular variable. So A is true, B is true, C is true. Okay, so now we have true and true, or true. So we're going to do the parentheses first. So true and true, it's an and statement. If both sides are true, the whole thing is true. So we end up with true here. Then we have true or true, and in an or statement, if either side is true, the whole thing is true. And so that gives us a result of true. Now down here we have true, true, and false. So we're going to plug in true for A, true for B, and false for C. Okay, so again we have true and true in our and, so that equates to true. We have true or false, and because either side can be false, because either side can be true, the whole thing is true, and we do have one side that's true, this also results in true. In this last example, we have true, false, true. So A is true, B is false, and C is true. So true and false is going to give us false. Or true here, and either side is true, the whole thing is true, so the result is true. Okay, I'm just going to run through here this false one here. Hopefully you're getting the gist of these. If not, certainly send me an email or post something out to Piazza, and I'll go over this with you in greater detail. All right, so here we have false, true, false. So plugging in false for A, true for B, false for C. So we have a false and true. Both sides have to be true for the whole thing to be true, so it's a false. We have false or false. If either side is true, it's true, but both sides are false, so the result comes out false down here. All right. The last thing we wanted to talk about is a Boolean variable as a condition. We can actually define something as a Boolean variable, right? And Boolean variables contain a value of true or false. Now we only need, if we have a Boolean variable, we only need the variable itself in an if statement. So for example, we have Boolean temp equals true. We can say if temp equal true, we can do that, and that's perfectly fine, but it's redundant because temp is already a Boolean variable. We already know it contains either a value of true or false. We know an if statement will only act if something is true, so we can just say if temp. And if it contains a value of true, it will act on the if statement, and if it contains a value of false, it will not act on the if statement. Right? So what you may encounter as you're working in WebCat in Lab 3 or Lab 4 is if you actually have a Boolean variable and you're doing a comparison and you do this here, WebCat may deduct a point or two, and it'll say that's not very efficient. It wants you to do this because this is more efficient. All right, so if you see that, think of this Boolean comparison here and just make that change in your lab. All right, so that brings us to the end of decision structures. Certainly